hills and different topographies of the fitness landscape. And so genotypes that are positioned high up in the fitness landscape have high fitness, and genotypes that are lower in the fitness landscape have lower fitness. And so what they're also plotting here are these sort of evolutionary trajectories that if you start at different points in the fitness landscape, you can gain mutations and move up in the fitness landscape and reach higher and higher fitnesses. And then these circles are regions where there is stabilizing selection and you get stuck in these different regions in the fitness landscape. Lots of people have studied different proteins of HIV and mutations within those proteins and come up with these fitness landscape structures. This is for the ENV gene. This is the thing that binds to the human cells, the CD4 cells. And so obviously these mutations have a huge effect over whether or not it can get into the cell, and so have a huge consequence for the fitness of the virus. I'm showing you this just to talk about fitness landscapes a little bit more. I think it's a really nice way to sort of visualize how populations sort of mutate and gain fitness and evolve over time. But I'm also showing you this fitness landscape because this is different than the other fitness landscapes that we've looked at. The other fitness landscapes had just a single peak. Do you remember for antibiotic resistance, 4 mutations led to this high level of antibiotic resistance? 5 mutations were bad, 6 mutations were bad, 3 mutations were not as good as 4 mutations. And so it gave you this one peak where the optimality was 4 mutations. And so that might paint a very simple picture of how evolution works, that you sort of get to the optimality and it's very easy to get to the optimality. And then you experience stabilizing selection once you're on that fitness peak. However, actually, a lot of fitness landscapes are not that simple. They have all of these different topographical features where you have hills and valleys, and you have different local peaks. So this is a local peak, that's a local peak, this is a local peak, these are local peaks over here. So you can see there's these evolutionary trajectories that take the population to a peak and then it gets stuck. And so this is the main issue with really predicting evolution, is that if you have these really complex fitness landscapes, so first off, being able to measure these topographies is still very difficult, even though we do have some examples. But then being able to predict where the virus is going to go and where it's going to end up is difficult. Sometimes if you start out here, there's sort of a main attractor to this region, and these genotypes will be selected for, and that's where you'll end up. But there's other regions where if you start out here, you can end up in lots of different locations in the fitness landscape.